I'm John Joshua Babylonia from ECET 32. Now here to apply what I've learned for the digital input and output regarding microcontrollers, specifically for the chip PIC16F18875. Now, the first step is to, of course, create a new project. And then we select the appropriate chip, which is PIC16 F18875, and click Next, and select the compiler XC8. Now, we'll go to the directory in which we should save this in the folder SA1, short for Summative Assessment 1. So we click here, and then we'll name the project SA.I or SA1 as well. Click Finish, and we'll start creating the new project. Now, we'll go on Tools and click on Embedded and click on this MCC. Then we'll go ahead and select the classic version and finish it because we have already the required contents and packages. Now we can formally start the project. So for the output, I would like to select RA3 or port A here along with the 3. I'll assign that as an output. And for the input, I'll assign um, something along with 3 as well. So I'll go with port B3 for the input. Now, navigating to the pin module, I'll rename RA3 or our output as our LED. Then we'll uncheck analog because we have digital signals. And for RB3 or our input here, we'll rename it as switch. And then we'll check WPU or the weak pull up. Now, going to our system module, we have here the default HF into SC, the internal clock set at 4 MHz divided as 4 with an effective clock of 1 MHz. And then we also have low voltage programming enabled already. So going ahead with this, we'll start to generate the code. Now generating. Okay, it says here generation complete. So in our project now, we have here in our source files main.c where we can now have our code. So for this code, I would like for the LED to turn on and off alternatingly for about half a second on, half a second off, if I press the switch and hold it. If I do not press the switch and release of it, the LED should just turn off completely. But then if I press the switch, it should be alternating blinking 500 milliseconds every time. So to that end, we will get first the value for the switch. So that would be if the switch has the value, or let's get the value of it. If it has a value of 0, or if it is pressed on, if it has If it has been pressed and hold, then um, we should be we should input the code where it alternates. So we'll have the delay in milliseconds as 500 milliseconds, where the LED is toggled. Okay, so for the action of having it having the switch not pressed, so else, or the alternate um, condition would be that the LED should be turned off completely, that is set low. Now we have completed the code, so we'll go ahead and click the hammer button to compile it. So it's building the code. It resulted with a build failed. Now, looking at our our pin module, we can see here that the custom name for our switch was actually switch. So it's wrong spelling. So we should replace it with the correct spelling, switch. Now going back to our main C, because the pin name was actually not switch. Typo error right there. Sorry about that. Now we will build it once again. So compiling it once again, loading. So what have I done is that I generated the code for our revision here. Now that we have a complete generation, we can now go to our project once again in the main C file, and let's try to build this again. Build successful. So yeah, um, the problem was that I mistyped the switch here and I did not generate the code once again. So it was important that every revision that I have with the pin, interrupt, and system modules, I should always generate another code. So there it is. So the source code is not wrong. I just forgot to generate the code for the revised pin. Now that we have our code revised, we can now exit mplab x IDE and now go to IPE. So we have here mplab x IPE. Now, now, you can see it right now, but um, I have already connected the peak kit tree here. So pressing connect, clicking OK here. So it was not found. So it has to be reconnected once again. Okay. In times like this, it is better to reset nplog xipe because there are times that it really has many errors like that. Okay, once again, we connect. So, this error was actually caused because the power supply is not yet plugged. So, I will now plug the power supply because I forgot. Now that we have the power supply running, we will disconnect the peak kit and plug back again the USB and then attempt to connect again because I forgot to plug the power supply. But now this time the power supply is up and running. Now we are connecting. That's why it could not detect the target voltage VDD because the power supply was not plugged in. So now we have the target device. Our PIC16F18875 is already found. Now we'll go to the advanced settings, enter the password, and put on the power, check on power target circuit from peak kit 3 and set the voltage to 3.125. Now going back to the operation, we'll browse for the hex file in the dist folder. So we have here on coding SA1 on this folder, on the dist folder, default production. Here's the hex file. It is loading the code right now. Ah, okay. It has already loaded successfully. I did not see that. Should scroll down. So now we'll press to program it. It's programming. And programming is complete. Now that the programming and the code and the hex file is now on our chip, we will now move to the hardware right here. Wait a moment. Okay, now we'll move on to the hardware. Here it here it is, the hardware. So first we have here is our power supply. Um, it can't focus right now, but it is rated from 1.5 volts to 2 volts in 500 milliampere amperage. And it is connected here. This is the output, like a 9-volt battery. And then it is connected by a wire through a voltage divider network so that it would give off only 5 volts. It is designed by that. The other resistors are just miscellaneous. We only need these two resistors right here. So this would have the ground, this black wire, on this side of the breadboard, and we have the white here, which is the supply on this side of the breadboard. So here's the ground and here's the positive supply. So this the positive supply is connected, of course, to the VDD here, and the ground is connected, of course, to the VSS here. Same thing over here on the VDD on this side and the VSS on this side, or the ground. So the other connections we made are on the switch on the port RB3, and we have our output here on port RA3. So it's hard to see because of the super small dots. So here we have our resistor in parallel with our LED, which are then connected from the output here towards the head of the resistor, and the resistor is in series with the LED, which is then connected to the ground. So that is the circuit. Now I'll go ahead and disconnect peak kit 3. Now it is disconnected. Now here's the switch. If I press this switch and hold it, it should have the LED turning on and off alternatingly for 500 milliseconds. Let's try it. It it's working. Now if I let it go, it should be permanently turned off until I decide to push it again. As you can see, it is completely turned off. And if I press again, it is pressing, it is turning on and off alternatingly. So the project was a success.